So we are to Unit 5, Lesson 1, and Unit 5 is our last unit of the semester this year. So this extends quadratics into more general polynomial functions. A quadratic is a specific type of polynomial, but when we talk about functions that have not just x squared, but x to the third, x to the fourth, x to the fifth, and so on, those are all polynomials. So we are expanding our definition of different families of functions. So in this lesson, we're going to identify polynomial functions and graph them using tables and what's called end behavior. So end behavior is kind of a new topic. What I want you guys to understand is that as we go on in Algebra 2, these units get more dense with information, so my videos may get a little longer or may seem a little drier. So it's important that you do things like take breaks, pause the video, maybe just rest your eyes or your brain for a minute, but don't just try and power through the video, because if you go through it and kind of just write down what I write down and don't really pay attention to it, the notes don't really sink in. So I think this should be the part of your lesson that takes the longest, because you're really soaking in that information. And then when you work on practice and things like that, you can reach out to me for help. So just keep that in mind. Now, mostly in this lesson, we're going to talk about defining polynomial functions. So the things I want you to do is kind of break down this language. Polynomial, poly, is a prefix that means many, okay? Nomial comes from number. So polynomial, translation, means many numbers or many terms. So a monomial is a polynomial with one term. A monomial, an example of a monomial, is 5, is a monomial. 4x, 6xy, those are all monomials, either a number or a number times a variable or a number times multiple variables. Okay, now a polynomial function looks like this. This looks like a lot of gibberish. Oops, sorry. This looks like a lot of gibberish right now. But a polynomial is a number with a bunch of monomials with different degrees, different powers on them. So when we talk about this, the leading coefficient, the degree, the constant term, the leading coefficient is the number times the variable with the highest power. And that highest power is what's called our degree, okay? So I'll show you specific examples of that. So some common polynomials, ones we've already worked with, we've worked with constant functions. A constant function is f of x equals just a number, no variable. Constant means it doesn't change. This has a degree of 0. A linear function, 5x minus 7, is a linear function. It has a degree of 1 because 5x has the highest power. X to the 1, degree of 1. Quadratic, the highest power is 2, so it has a degree of 2. Cubic, the highest power is 3, it has a degree of 3. Quartic, a little more obscure, but has a degree of 4 because the highest power term is 4. So identifying polynomial functions. This is what I really want to focus in on, because this helps us define them using specific examples. So these specific examples are going to help us round out the definition of a polynomial. So when we look at example 1, part A, what that shows us is 2x to the third plus 5x plus 8. So this right here is a polynomial function. And I'm just going to go back to the definition and reread this really quick. This is the main thing. And I didn't really cover this in depth, but a polynomial function, the exponents are all whole numbers. The coefficients are all real numbers. That's the main thing. So the exponents for this are all whole numbers. The variables, their coefficients, are all real numbers. So this is a polynomial. Part A is a polynomial. And for that function to be in standard form, the highest degree has to be first, second highest second, and then in descending order. So this is a polynomial, And this is already in standard form, so I'm just going to say already in standard form. If this weren't a polynomial, I would write not a polynomial. Now, this is the part that I want us to recognize. The degree and the leading coefficient, or degree type and leading coefficient. So the degree of this polynomial, degree is 3, because the highest power is 3. That's in that first term. Type, highest power is 3. If we look at the little table at the top, we call this a cubic function, or a cubic polynomial. And then its leading coefficient, I'm just going to write LC for leading coefficient. The leading coefficient is the number times the first variable, or in the term, that's the first term, the number times the variable. So the leading coefficient of this polynomial is 2, okay? It's 2. In our next example, when we look at this, the coefficients, yeah, they're weird, but they're real numbers. And our powers, our exponents, are all whole numbers. So this is a polynomial. Now, this is not in standard form. So I'm going to rewrite this in standard form. The only thing I have to do to rewrite this in standard form is take the term with the degree of 4 and write it first. Take the term with the degree of 3 and write it second. And then this constant term has a degree of 0, so it comes last. So in this function, in this polynomial, our degree is actually 4. It's not just the first one you see, it's the highest degree. The type, if you look at the table, this isn't as important. This is quartic. That naming is not as important as knowing degree and leading coefficient. And then our leading coefficient is just the number times the variable on the first term. So our leading coefficient is square root 2. All right, moving on. If you want to pause the video and try these two on your own, feel free, okay? Now, in part C, looking at the coefficients, we're good there, but our powers, or our exponents, right? When we look at this exponent, the exponents have to be whole numbers. And more specifically, the exponents should be positive. So this is not a polynomial. Because this term with 7x to the negative 1 that negative 1 is not a whole number. So basically, to be a polynomial, you can't have any negative powers, you can't have any fractional powers, you can't have any variable powers. And that kind of leads into the next one, part D. This is not a polynomial. Because of 3 to the x power. This power, not a whole number. So we can't have variable powers either. So this, I know I just spent 9 minutes defining one thing, but it's important for us to recognize those things before we can apply them. You got to know what something is before you can talk about its properties. So I'm going to spend a few more minutes on this next page just with evaluating. It's not too bad. And I'm probably going to separate into another video end behavior, okay? Because that's a different concept. So it's going to be a couple videos. It's going to be a little long, but it's a lot of information I'm cramming into one unit. So keep that in mind. So evaluating, we've done this before. Evaluating a function for an x value. So evaluating this function, I'm going to show you how I want you to write it. We're substituting in 3 for x. So that means this is f of 3. So that means wherever I see an x, I substitute in 3. And the important part here is to put that substitution in parentheses. okay? Putting that substituted value in parentheses is extremely important. And then past that, it's just order of operations. So I'm going to evaluate all the powers first. So 3 to the 4th power is 81 minus 8 times 3 squared is 9 plus 5 times 3 minus 7. Okay, so I took care of all the powers first, all the exponents. And then past that, 2 times 81 is 162. 8 times 9, 72. 5 times 3, 15. And then minus 7. Now, could you just plug this all into a calculator and kind of have the calculator do the work for you? Absolutely. I do not care. But make sure that you understand when you're dealing with negatives, when you're dealing with all these other things, use parentheses when you're substituting, okay? But that's all there is to it. Evaluating a polynomial is just substituting in a value and evaluating using order of operations. So, this is the end of the first video of this lesson. This is a big lesson. So, you can move on to just a mini practice of this and then come back for the next video on end behavior and some graphing, okay? So, I've got some short mini practice that you can work on, or you can work on some of the paper and pencil practice. Whatever, it's up to you. But then come back for the second video from end behavior.